Okay, in the interest of continuing with our lives, I'm just going to go with, I'm going to share the unformatted HTML today. Sorry about that.
That's fine. I'm going to say up front that I found this for some reason really hard to get my head around a lot of this stuff. So excuse me if I'm a bit slow on the uptake with some of this.
I think partially it was because it builds a lot on the idea that you had just recently read S3.
Yeah, maybe.
Like that's what I kind of felt like it was, because it was like refer to S3 and I'm like, S3, you think I remember that far back, buddy? Like,
yeah.
Anything. Look at this. See, it's just stuck on 88%. Okay.
We read that sometime before Christmas still, right?
Oh yeah, so I guess like
yeah.
So I was like, oh yeah, because we're doing like two sessions per chapter at the moment, so it's further back than you think it would be. But then obviously Christmas as well. It probably was, you know, 6 weeks ago or something, maybe more.
Yeah. Then it makes sense that I also didn't remember so much of S3. Wow.
Oh. Why is it getting stuck there? It's so sad. I'm going to rename it. Sorry, I'm just like, I'm very distraught now. Maybe it doesn't like this. Okay. It could also be that I decided to try and use a very large S4 object to illustrate some points, which might be causing it issues. I don't know, it seems to work fine earlier today. So run. Go, buddy, go. I'm just going to assume this. Okay, so we started with generics. So generics in S3 and S4 objects are the way that S4 and S3 do object-oriented programming. And I feel like what I read somewhere was the idea of it being function-oriented, object-oriented, or there's maybe a better terminology for that. But the kind of idea behind S3 and S4 is that the encapsulation and the reproducibility that you might get from an R6 object or in kind of classical object-oriented programming is really centered on the functions that you create. So generics are the functions that find the specific methods for S3 or S4 classes. Some common generics that we use all the time are mean or summary or print. They're all very common generics. And with S4, we create a new generic using the set generic function. So it's pretty simple. Set generic, my generic, sorry, that's gonna keep going off. Function, standard generic, my generic. This is kind of the format. Hadley says, don't use curly braces like this. So when you do the set generic, my generic with the curly braces, that apparently has another meaning. He doesn't really say what that other meaning is. He says, don't use it. We should also try to use lower camel case. So that's lower uppercase, basically any other word here when we're making generics. And we set S3 generics using the following kind of formatting, right? Where we just said, my new generic, function of X, use method, my new generic. So that was how we made the S3 generic. This is how we use an S4 generic. So signatures. The only like argument we should use for set generic is signature, and signature describes how to do method dispatch for us. So I guess we don't have to use this, but the purpose of using this is that we can say specifically which arguments we want to include in the method dispatch, I think. I was also a bit lost on this part, like the signature X. So that means we can make a method which asks you to provide arguments, but they don't have to be involved in dispatch. So when we choose which method to use, we don't need to pay attention to the verbose or the quiet arguments. if we're using signature. Is one way where we do it. Basically, we use signature if we want to say, pay attention to this argument, I think. Does that sound right? No? And shaking your head. I think that's what he was trying to say. I also was confused.
Well, I also didn't really get it. Yeah.
Oh, it
No idea.
Okay. Yeah, I mean, this is what he says basically, is that you don't have to set the signature when you create a generic. So if you create a new generic, like for example, a new print function, the print function is going to use all of the arguments that you put to it. So for example, if you give it a person object and you give it a place object, it will use the object type when it does method dispatch or class type. But if you wanted to have another argument in your print, which was like quiet, you could use signature to say, use only person and place and ignore the quiet when I do method dispatch later on, is I think what we use this for. Right, I think that's it. Methods. Okay, so methods are the specific implementations for an object for a generic. So once we've made a generic is kind of useless unless we make it a method to actually do the things the generic is going to do, to say, do these different things on these different classes. So the three important, when we do set method for S4s, we use a call to set method. The important things are the name of the generic, the name of the class, and the method itself. So the basic kind of way is you say set method, my generic, the class that you're doing it in, and then here is how the method actually functions. When we're doing S3 methods, because it did that like dot whatever to find the dispatch, we could just make a new method by basically making a function called print dot class name. So for example, if we were doing it with mean with an S3, say mean dot class name, and then we would have a new method for an S3 object. With S4, it's a bit more rigid, which is something he also talks about with trade-offs, that the advantage of S4 is that it makes you be a little bit more rigid, which can be very useful when we're working with large teams, because if there's more rigidity, you're not relying on kind of common behaviors that the team does to make sense with one another. It's that things won't work if you don't build it the right way, which is kind of a good safety message. So we can find all the methods that belong to a given generic just by calling the methods, or the class with methods class, or we can find a specific implementation of a method by calling select method generic class. So the most common S4 generic is show. And here what I did is I loaded in an object which is actually the human genome, which is an S4 object that I use all the time, actually. And I don't know why this didn't look basically, but we can load in it with library S4, and we can call is to see what kind of object it is. So that's what, this is what is. It is BS genome underneath the annotated class. So it is an S4 object, I happen to know it. And it has this special print function that if I call print to BS genome, so here print, well, if I just print it here like this, it formats this really pretty way where I say human genome, organism, genome provider, release date, how many sequences are in it. And if we want to see the actual dispatch, so if I wanted to say select the method show echo BS genome, this will show me the kind of verbose print method that is for an S4 BS genome. They're not necessarily always going to be this complicated. So for example, you can make a show method that is similar, such as the example of person, where we say set method show person. Show always takes exactly one argument. The argument is object. And this, for example, would just print the name of a person object, name, age, separator. So, right. when we deal with S4 objects have slots, as we talked about last time, which we can access with the @ symbol, but we really should not access them with the @ symbol. What we should do as nice coders is we should create accessors and getters for people who are actually going to deal with our objects. Because, for example, if we're working on maybe at some point I'm going to change the name of the slot a little bit because, oh, I've got another slot that also was called Gene, so now I want to call this Gene that is down. And if you're having people rely on the names of those slots, that can be problematic when they update the package, the name of the slot has changed, all of their code is broken. So if you always provide them with getters and setters, which are exactly what you think they want to access, it should be more reliable. So for example, you can access, so here is one way to access all of the sequence names that are in the human genome. So we could get it with the genome @ slot seq info. A slot itself can have another slot, so @ seq names, chromosome 125. But because this is a well-developed SQL package, there is of course actually a getter, which is just seq names. And this is the way you would normally interact and get the sequence names of this S4 object with our getter. So we can also basically make generics if we want, and we make generics and methods with set generic, set method. So this is an example where basically we are creating a generic method, which is going to be called name. It's going to be function X, standard generic name, basically assigning it. Then we create the method name, the BS genome class. We'll have a function which will return, which we'll call X, go into the metadata slot and get the common name. So basically what this should do is, ignore the name that's from these. This will now give us the name of human. This will now give us the name of mouse. So this is kind of how we make generics, make methods, how we use them. We should also provide setter functions. So if we make a setter function, if we make a getter, we should make a setter. People, again, shouldn't have to use the slots. This is just from his example because I didn't want to work one up with a setter for the name of the human genome. But again, it's the same kind of idea, except this time we want to include the assignment operator within the call. So here, name little assignment operator is function X, value, standard generic, same with method. Here is where we actually will go to the slot. And the other thing we should always be sure to do is call valid object on an item, because basically if you're allowing people to set something, if you don't have a call to valid object, they can put random nonsense there that you don't want to be in your object. So you should always then call valid object in the setter that you provide them. So here, name John Smith, John letters, you can't have a vector here. All right, exercise 5.4, which I very hopefully didn't write down what it said. Oh, so I just did this one. And then I also went through this one, but I'm happy to go through what I did for exercise 1. So up here, we're making the class person. We're making the person class. So we set class, as we learned last week, set class, person, the slots are going to be name, which is the character, age, which is a numeric. We give it a prototype, which should be kind of the default setting. It's good to put the types here. We make a valid person. Basically, this is now whenever we call that valid object, this is how it's going to call the valid object using set validity. This function here will check whether or not something is valid. And then we'll create a generic. We'll create a method for that generic. So this is just going to basically return the age. Again, we'll create a generic for the setter of age. And then we'll create a method for the getter of age. So the way this will work is you'll say age with the assignment, class, function, X value, go into the slot, assign it, call valid object, and then return the object itself again. Right, so here, for example, We create a new person, Al, new, Anna-Leigh, age 27, and this should run fine. So, ta-da, age, we'll say this, age 27. Okay, now if we try and tell it none of my business what age you are, we get an error. So this does not work because we've set up this validator up here. Did I? Oh, so this is kind of cool. I thought this was also interesting. I went through the answer book for this one, and I thought their examples were pretty interesting. So I thought I would go through it. So if when you Google advanced R answers, this is from this, but I thought it was interesting. So because the first time I read the question, it didn't make any sense to me. Like I just did not understand the words. And then I read the answer, I was like, oh, so what happens when you define a method with different argument names to the generic? So basically, what if you try to define a method that actually doesn't make any sense for the generic object that you're using? So we'll start again with the person class, make our person, we send a generic, which is name. And now we set a method, which is name, person, function. So now let's try and make a show method for our person. So show is the S4 version of print, essentially. So we can use the formal function to show what kind of things an argument needs. And this says that show basically takes in a single argument. The argument is object. So what happens if we don't use object when we make our method of show? So let's try and make a show. This person, and again, this is just going to be the way that it's going to print out. And rather than using object, my method actually calls function of X. And I say cat name, X is a tired grad student. So this will first off give me a warning. So it'll give you a warning, show, signature, person, argument, and method definition changed from X to object. But when I print it, it will still print out correctly. So if it can kind of do this forced evaluation, it will. However, if we tried to do another print method, which would say show person, which is a function of X and Y, and now I say X is X at age years old, let's just say Y, this will give us an error. So if we try to kind of overload these shows, or if we try to overload generic with functions, with arguments that don't exist in those generics or in those methods, we'll get errors. If it can be forced, it will succeed, but it'll give you a warning, which I thought was kind of cool and interesting, so I thought it was worth it. Cool, method dispatch. I would have loved to make my own complicated diagrams for this, but oh my goodness, so many emojis, I was not going to do that. Okay, so the thing that makes F4 kind of complicated is two ideas. So idea one is that you can have multiple inheritance, and idea two is that you can have multiple dispatch. So with multiple inheritance, a class can have many, many parents, and with multiple dispatch, a generic can use multiple different arguments to pick a method. So to illustrate this, he uses this kind of complex emoji graph, which I think is kind of cute, right? Like this inherits from this, inherits from this, inherits from blank face, and it also inherits from cat, which also inherits from cat. Sunglasses guy inherits from both sunglasses and smiley dude. So single dispatch is pretty simple, is that when you are deciding, you've got your object, what method am I going to use for it? Well, you're going to start with the most specific and go kind of back. So if there's a method for winky, tongue sticking out guy, that's the method that's going to be chosen. If there's none for that, we move here, and we keep going until we basically reach the any, if an any method has been defined. And that means this will run on basically anything. any is considered farther away from everything than any other actual defined class. So what I mean with the like any is, let's say I can make a new generic called potato. And this generic named potato is a function x, which has a standard generic potato. Okay. This set method potato, I'm going to say will work on any object, function x, and it's always just going to print, oh no, they stole me potatoes. If I call potato on BS genome, which is of the BS genome an annotated class, it will call, oh no, they stole my potatoes. If I call potato on a granges object, which is another S4 object, which is not, I think, even related to, I don't think is related to, now I'm going to have to check, is granges, yeah. So I guess it shares annotated with it. Okay. It is, of course, shows us all the different classes that this thing is, which compare is granges to, for example, is genome. So, yeah, of course. I'm not going to remember how to type it in. So the way basically we can have this any method is basically if we want something to eventually be called, if we want a method to be called, we can give it in any class. But dispatch works with, we start with the most specific and we go more and more general until we reach any, or if there's no any for the method that we've called, then we get an error. Multiple inheritance, again, you start from the most to the least specific. And the way we choose is whichever the shortest path is. So let's say there is not a method defined for a smiley face guy, but there is a method defined for sunglasses and a method defined for eyeball man. The method that will be used in this case will be the sunglasses one, because there are less steps away from sunglasses man to smiley face. The idea that any is the furthest thing away is basically if there were, let's say, another method right here, which was any, that one would be called last if there were any specific cases that were instantiated. So that's kind of this idea with it's always considered the furthest away in steps. Multiple dispatch works basically in the same way, because with any method you call, it can have a method which works for a blinky guy and a blinky guy. So when you call the function, if I've got a tongue sticker outer and a tongue sticker outer, same kind of idea. And it will try to pick the path which has the least number of steps. So shortest path that fits the least number of steps is the kind of idea behind method dispatch. So if I've got a method that works on both, let's see, as an example. There we go. Okay, so let's say I've got a method called, I don't know, TED. And method TED can work on a G-range object or a genomic range object or a ranges or an annotated. It will treat this, it will pick the one that is the first, like the most specific method, it will use that. So for example, if we had a show method defined for employee and a show method defined for human, it would print the method for human before it would print the method for employee, or it would print employee before it would do human. And if we had a function that worked on employee and human, it would choose for the first argument, it would choose employee. For the second argument, it would choose human. Does that make kind of sense? So basically, whenever we define methods, it will try to pick, like if we have multiple names, multiple generic S4 functions called names, it would try to pick the most specific one that matches the arguments that you've given it at any time. edit. This is what this emoji block is trying to tell us. So if I've got a function which takes in blah and blah, first I will choose blah and blah. If there is no method that matches blah and blah, I will choose wink and blah or blah and wink. It's kind of what it's trying to say. I liked the emoji thing, but then I was like, how am I going to read this aloud? I don't have names for all these. Anyway, okay. So we can also use S3 classes as S4 objects. And to do that, we use a call to set old class. And basically, this is just saying now we're going to say this S3 object of data frame or an ordered factor or GLM is now going to be treated as an S4 object. You should give specific and full S4 definitions, though, if you're going to do this. So if you're going to make a new thing, for example, range numeric, you should actually tell it what it's going to do. So for example, if I wanted to make a range numeric that basically was I think this is kind of like a factor. I should actually set out how it works before just trying to inherit the functionality of an S3 class. I should give it a contains, a slots, and a proper prototype. If we want to convert an existing S3 generic to an S4 generic, we can just use set generic. Now it's an S4 generic, and it'll work on S4 objects. So if I wanted to, for some insane reason, find the mean of a genome, if I said set generic mean, and then said set method mean BS genome, and then defined some crazy method where I would get the average of a genome, which makes no sense at all for you to do, but I guess you could theoretically do it. We would do that by just saying set generic and then defining our method. In this case, the existing function that you've got automatically becomes the set select method mean for the any class. So basically, if I didn't define anything for my genome or my genomic range or whatever I wanted to do that wouldn't make sense to do a mean, the existing average or mean here would be the new kind of any class definition. Right. So for the exercises, I went through exercise 2 on this one because I thought it had a kind of interesting use case. So I skipped this one. That seems really annoying, so I didn't do it. Define a method, length method for the person class. Oh, did either of you guys do this one? No? Okay. Define a method, a length method for the person class. Okay. And the reason I thought this was an interesting case. Okay. So length is an S3 generic function. So it's S3, but now we're going to define it as an S4. So we just say set method length person, and I'm lazy, so I'm just going to say that anytime it receives a person class, it's going to return the height of 5 feet 3 inches. And let's see what the length of Anna-Leigh, which is the S4 object we made earlier, what the length of Al is. And then we can also define an S3 function. So the length of person, remember this is how we define S3 functions, where we say method dot class function do whatever. And basically what I thought was interesting, so this prints 5 feet 3 inches. If we define an S3 class, we will still get 5 feet 3 inches because of course it looks for the S4 definition. I bet this won't work. If we do this, yeah, because I already created the thing for it. Let's see if I can do this. if we had not defined that length function there for an S4 class, it would have printed 160 centimeters. I have tested this. So I thought that was kind of cool, is that the S4 object, if it doesn't have an S4 class, but there is an S3 class that would use it, it does use that S3 class. But if you try to like define a method for an S3, and use it on an S4, and an S4 happens, of course it does pick the S4 method first, which I thought was interesting. Okay, straight up. So I basically, I think there are a lot of trade-offs between, no, let me rephrase this. When I was reading his thing about why you want to use certain trade-offs, between S4 and S3, the advantage of using S3 is it's easier to use, it's simpler, there's less structure. I generally, I at least, I don't know. What do you guys feel? Unmute yourselves. I have no more to say. Personally, I don't like the less structured ones. I would prefer rigid structure.
Yeah, I agree. I thought like I didn't really feel like, and maybe they weren't presented like this, but I didn't feel like the arguments were like super compelling for like S3 to just be like, it's easier or whatever. And I was like, but yeah, I mean, okay, sure. But I appreciate why that can be a plus if you think it is easier, which maybe you don't. But like, yeah, I was like, I don't love the kind of move to be like, first, because I guess with this kind of book, it feels like it's trying to set some standards. Because it kind of like is building where there isn't like a cohesive existing reference guide like this. So like it's offering a lot in one place. And so that means that it is going to be like the entry point for a lot of people to these kind of things. So then I feel like it's a shame to have the recommendation be like, do the thing that's less rigid, because that will then influence lots and lots of people to have that as their entry point, like their like go-to, which maybe, I mean, I guess like I guess you can make arguments obviously for that being fine and everything, but I think there are big advantages to having more like structure. And I think structure can make things easier as well, because you're like, oh, I have to do this, like these are the steps I have to go through, so you're less likely to do something wrong because you can't. So I still feel, I mean, personally, I feel like I prefer the ones that don't have that kind of freedom about them. And sometimes when the argument did seem like, well, ultimately it boils down to S3's better, but better just seemed to mean doesn't have the structure.
But I think he also said that like S3 would be easier to use for an individual because you don't have to set up so much, and if it's just you working on it, you will know the structure anyways. And S4 makes more sense if you are working with a larger group on the project, and so that everybody has the structure, the same structure. And yeah,
I mean, I get that distinction, but I think that's one way in which kind of bad coding practices get embedded in people, because like you have a way of working that's like when it's just you and you know everything, and then it's like even when you come back to it in a year, you mess it up because like it doesn't have the way you thought was super logical, and definitely the way that you would obviously always do it turned out it's not the way you would do it once you've got like a year's more experience. So, but I can see there being a benefit to having something that is like quicker for like purposes when you genuinely are doing a project that's not going to have any longevity to it.
But I feel like, at least personally, if you're working in R and you're doing something quick and dirty, you're just going to write functions. You're just going to do functional programming. Like, if you're doing it quick and dirty, you're not going to go to like, oh, I'm going to make objects, because it's like not a classical R way of thinking. So yeah, I don't know. We need someone in here who's like, yes, I'm so pro S3. Like,
yeah, which sounds like possibly
Yeah.
everyone else.
yeah.
Yeah. I think it's really interesting that you two have been working in kind of fields where S4 is used a lot. Because I don't use classes at all in R really. But I guess obviously you'll have had that experience, so that will impact how you see S4 versus S3, I guess. So maybe people who, if they've only used S3 or have primarily used S3, are coming at it with that viewpoint as well. So maybe there's some familiarity as well, because it is widely used, right? So
Yeah. But I must say, before I read the book, I also just knew it is S4, but I had no idea what that means, or like, what's everything that's behind that actually. So yeah, I liked to read this stuff.
I think it was really cool to read this chapter because so the repository he mentions in the book, which is Bioconductor, it's kind of like the the computational biology version of Fran. And I'm like, oh, this is very inspirational. Like, I feel like I could now write my own bioconductor package after like going through this little doodah. I'm like, yeah, I see how like I could make these S4 objects. I could inherit from other ones. Like, I'm seeing it how it makes sense. I'm excited now. S4, S3 versus R6. So R6 versus S3. The ones I highlighted in the example were, I think, just basically the essential idea behind, I'll show the screen again, behind the two ways of doing object-oriented programming in general, which is, right, when you S3, S4 are, in general, object-oriented programming, is there is ambiguity when you call plot on data, plot for a bank heist, plot for land, plot for a movie. And when we use R6, there's never any ambiguity here, right? Because a method belongs to an object rather than a method existing in the namespace and us having to define methods for it, or generic existing in the namespace and us defining methods for it. I thought this was just interesting because I felt it highlighted the essential whole, like, this is how everyone else does object-oriented. This is how ours does object-oriented. Which I can also see the other things he talks about is, I can also see having to do this all the time actually being somewhat annoying. Basically, if you had to create a new plot function every time you had to create a new item or a new object, I can see how that would start to get irritating if you had like a lot of objects. And if it was like minorly different, like for example, if you take the employee and person, right? The print functions aren't that different between employee and person. So it's easy enough to do that kind of inheritance. And then going on and on. Whereas if you had to create a complete system, I don't know. The other thing that he talked about was the idea that there is some ambiguity with whenever you call something for an S6, for an R6 object, you are risking also modifying it at the same time that you're calling something on it. So you are simultaneously returning and doing something, which he said can be a bit like dangerous to do. I don't know. I think also if you use the data table package in R, you're used to that kind of thing, so that doesn't seem that shocking to you. Whereas like I can see where it would feel shocking if you weren't frequent. But I wonder the data table package might just be written in funky R then.
Yeah, I mean, I think that's one of the kind of like what's the word I want? Kind of points of disagreement, I think, between data table and dplyr is this idea of like whether modifying like that is acceptable. And I think, yeah, like as somebody who uses data table a lot, I'm very used to that now. So I don't think, to me, it doesn't feel like well, it feels like it's a case of like, as long as you understand what's happening, you can behave in a way which adjusts for that, or not even adjusts for that, but like accounts for that, because like that's the class that you're used to using, then you'll be writing stuff in a way that is appropriate for that. I guess if you didn't realize that was happening, I can see how obviously that can be confusing. And it might mean that you have to be more careful about some of those things, but which is also true in data table. Like I think people who come to data table who are quite new to it spend a bit of time being a bit like alarmed by the fact that stuff has changed, or not, or you know, changed which they didn't expect to have changed or something. Yeah.
Now I'm getting a bit scared because I haven't used it so much yet, and I used it lately at some, like, I don't know, before Christmas a bit, but I didn't realize that anything is changing there, so now I'm getting scared.
Wait, you're always updated. You update it in the same call, versus whereas like if you do dplyr, right, you need to assign it back to itself, and it also doesn't copy on modify. It's great if you are using anything with like millions of rows, or like 50 columns.
Yeah, like it's one of the things that makes it really efficient. Yeah, that's good.
Okay.
I actually only recently learned the tidyverse because my collaborators here are using it. Like I was totally data table before, and I'm still like, why do we have to type so many words?
Yeah. But yeah, I can see like if you haven't used data table, and if you come through, I don't know, something that I thought was a bit interesting, which maybe relates to some of this copy modify stuff, but like was this the kind of one of the reasons why he suggested not using R6 was that it wasn't very idiomatically R. And what is idiomatically R at this stage? You know, I feel like it's a bit of a melting pot because you've got base R and you've got tidyverse and you've got kind of the data table way of doing stuff. There are some things which I'm sure are like in common with them, and I'm sure there is code that looks more like R than some other languages for sure. But I was kind of reflecting on that a bit, because I was like, the idea of like making a decision to do something this rather than that because it's more idiomatic, when I don't necessarily see that in R itself. But maybe it's a desire to, like, yeah.
I was updating my LinkedIn profile today, and then they have this new thing where they're like, "Oh, take a quiz. Like, how good are you at R?" And I'm like, "I don't know. How good am I at R?" And I start doing it. It's all base R, and I'm like, I've been programming in R for like 5 years now, like 5, maybe like 4 years now, and I'm like, I don't know this. Who knows this? Nobody would use this horrible way of doing things.
Yeah, I think that's so true. I think I've seen like other quizzes like that, like on kind of maybe like Pluralsight and things like that, where it's like it is a bit like test your skill level, and it feels to me like stuff that's been written by like it's like that, like maybe like the kind of like overseers are like not people who like, either people who like are really, really passionate about base R, or like people who are like coming from other languages, like overseeing like all these other languages, and they're like, okay, well we're not going to do the packages and stuff because like they're all like bonuses, so really we've got to keep it just to the base, the foundational stuff, because that's kind of like what a language really is, whereas R is so,
yeah, R is a bit of a mongrel, huh?
Yeah. But yeah, it's so weird when you see something, you're like, I think I can, you know, put my hand to like a lot of different R vibes, but like it's weird when you see stuff which is like, you're like, yeah, that's just not how I would do it at all, but I appreciate that it is a way that you can do it.
Whereas I would say like in Python it does seem there are Pythonic ways to think about things. Like, and that really does feel like a real thing. Like there's Pythonic ways to answer problems, and I buy that. Whereas like with, I agree with you when he was like, it's not the R way. I'm like, I don't know, man.
Yeah. I feel like the more useful question for most of those things, which is very hard to automate like a correct answer for, is kind of like get this outcome using R, rather than like, you know, make sure where would you put the parentheses in this example or whatever, and then you're like, okay, well, I could put it there, but I mean, that's not what I would do.
So what do you guys think you would use if you're using something R6 or S4? If you were going to make an object-oriented thing.
I think I would use S4, but also probably just I'm biased because I work much more with S4, and for me it also feels more natural, because I don't know very much Python or any object-oriented programming languages, so S4 feels more, yeah, I can do that.
I think I would go R6 because I think I found S4 a little bit more confusing, but I think that's could be like, if I worked with S4 for a while, then I think that would pass. I think it just kind of like didn't, and again, possibly because I've been working more in Python recently, maybe therefore R6 feels more, I don't know, but yeah, that clicked with me more.
Yeah, I have no idea which one I'd use. I think it would depend, if I'm entirely honest. If I were building a package from base up, I would probably use R6. But if I were relying on other R packages, it seems like since the ones I use are primarily S4, then I would just piggyback on them, I think is what I'd end up doing.
Yeah, I think it would be really context dependent, like what would make more sense, which is a bit annoying because it's like, it's probably not the case if you were going to like be doing this a lot, that you could just be like, all right, I'm going to stick to this one and I'm just never going to think about the other ones ever again.
Well, none are. You need to know how to read everything, even base R. Okay, metaprogramming next week. Boom chicka boom. My vote is that I think we can all read 17 picture on our own, and then skip to 18.
I agree with that.
I don't intuitively know whether do we want to split this up into two again? There's a lot of exercises. Maybe we do.
Yeah, maybe so.
Yeah.
One thing that I was wondering how you guys would feel about this, but so we talked about splitting stuff up, or we have been splitting stuff up. And I was wondering whether you would be up for doing like, we split them into separate weeks, but the same person does them, because from my perspective, sometimes I'd be a bit of a role and I could just do all of it and then have the presentations ready for the next week, or I could split it over 2 weeks, but it kind of means that I don't interrupt my flow as much, and then it means that you then get 4 weeks in between presenting rather than 2 weeks each time. So like, I mean, obviously you have to present 2 weeks in a row, but it kind of feels a bit like it might be more efficient for writing stuff.
I'd be happy with that.
Yeah, sounds good.
Yeah.
Okay. We can try it, and then if we're like, oh, it's awful doing 2 weeks in a row, then we can change it.
Then you can also a bit better maybe see where you do the split, because if you're anyways in it, then you see actually this is not so much, I take a little bit more or something like that.
Yeah, that's a good point. And you can be like, we could do it all, everyone read all of it.
Yeah.
So I think I'm next, if I remember correctly. So expressions.
Yeah.
Okay, so what looks like a good okay, 18.3 doesn't take
recursive function. Whoa.
Jesus. Okay. So maybe up to the end of 18.3 looks like it gets you about halfway.
That looks ish to me. I would say.
Okay, cool. Let's do that.
Okay. So we do next week
Yeah,
again. Yeah.
yeah, that's okay.
All right.
Cool. Thanks very much. That was, I think that was helpful because I think I've got a better understanding of S4
It was
than
a
I
very
did. So.
simple presentation with all the emojis.
So many emojis. Oh, wait. Let me show you guys. I looked at, okay. Wait, this is hilarious. Advanced. I did not draw the dispatches because that just seemed like so. I was not going to do that. That sounds awful. But I did look at whoever has been maintaining this like exercise solutions thing, and I just thought this was really funny. So I just wanted to share this. So they did do the drawings. Nuts.
Oh my
Message
god.
dispatch. And then I thought this was hilarious. Look at the graph repeat after me. I would keep my class structure simple and use multiple inheritance sparingly.
Oh my god.
Yeah.
Oh. Cool. Lesson learned.
Cool. All right.
All right. See you next week then.
See you next week.
Bye.
You. Bye bye.